From waste to wonder, how fungi can fuel our future. Sounds pretty incredible, right? Well, today we're going to dig into a really radical idea. What if we could turn our biggest waste problems into clean energy, with a little help from a hero you'd probably never expect?
I mean, think about it. What if our biggest waste problem is actually our most valuable energy solution? Right now, we see all that agricultural waste, straw, wood chips, corn stalks, as something we just have to get rid of, a problem. But what if we've been looking at it completely backwards? What if it's a treasure trove of energy, just sitting there, waiting for us to figure out how to unlock it?
So to really get why this is such a big deal, we gotta understand the corner we've backed ourselves into. Our world is basically facing this double crisis. Two huge, interconnected challenges that are defining our future.
Okay, so on one hand, you've got our dependency on fossil fuels. We all know the story there. It's driving climate change and messing with our energy security. But on the other hand, we have these growing mountains of waste. All the stuff from farms and forests, it's just piling up. And get this, when it's mismanaged, it contributes up to a staggering 10% of all global greenhouse gas emissions. That's huge. So you've got two massive problems, right? But what's so cool is that they might just share one single elegant solution.
All right, so if all this energy is just sitting there in plant waste, how do we actually get it out? Well, here's the catch. Nature's code is tough. Plants have evolved to be incredibly strong and resistant to breaking down. It's not an easy puzzle to solve. It's more like trying to crack a biological vault.
And there's a great word for this, recalcitrance. It's basically the plant's natural armor-like resistance to being broken down. Think of it as an evolutionary shield. It's what makes it so dang hard to get at the good stuff, the valuable sugars that are locked deep inside. And honestly, this recalcitrance, it's been the single biggest roadblock for making biofuels for a long, long time.
If you zoom way in, down to the molecular level, you'll see why. The chemical bonds in cellulose, plus other stuff like lignin, form this incredibly tight molecular fortress. It's a dense, crystalline structure that does one job really, really well, keeping those fermentable sugars locked away.
So, faced with this fortress, what has our solution been for decades? Pretty much just brute force. We throw everything we have at it. Extreme heat, intense pressure, harsh, corrosive acids. It's like using a sledgehammer to open a Swiss watch. Not only does this approach use a ton of energy itself, but it creates all these toxic byproducts that actually mess up the next stage of making fuel. It's just dirty, super expensive, and honestly, not very smart.
But what if we stopped using the sledgehammer and instead used, the key that nature already designed? Well, it's time to meet the hero of our story, white rot fungi. These guys are nature's master recyclers. Seriously, they are the only organisms that evolved specifically to elegantly break down the toughest parts of plants. They've already figured it out. Okay, so we have this natural superpower. How do we actually put it to work to turn waste into fuel? It turns out to be this really clever four-step journey of transformation. Let's walk through this biorefinery process. It's pretty amazing. Step 1, fungal culture. You just grow edible mushrooms, like oyster mushrooms, on all that agricultural waste. While they're growing, their root network, the mycelium, is doing the hard work. That's step 2, the pretreatment, naturally breaking down that plant armor. Then, after you harvest the mushrooms for food, which is a bonus product right there, you move to step 3, saccharification, a fancy word for using enzymes to turn that now pre-digested waste into simple sugars. And the final step, fermentation. You add some yeast and it turns all those sugars into clean-burning bioethanol.
So what's actually left in that so-called waste after you harvest the mushrooms? Well, check this out. This spent mushroom substrate is anything but waste. It's still packed with almost a third of its weight in cellulose. That's our fuel source. The fungus has already done the heavy lifting of breaking down that tough lignin, giving us a perfect, wide-open door to get to all the good stuff.
And you know what? The final step is just simple, beautiful chemistry. You take one molecule of sugar, and through fermentation, it becomes 2 molecules of ethanol. That's it. It's literally the same basic process that gives us beer and wine, but in this case, the end product is clean fuel.
But does it work in the real world? Oh yeah! Look at this number, 186.9. That's how many grams of pure ethanol they got from a single kilogram of sorghum waste in one study. This isn't just an idea on a whiteboard. It's a proven, practical, high-yield solution that actually works.
And this is where it gets really cool. The true genius of this whole system is that it creates a closed loop. The story doesn't just stop when you make the fuel. In this system, absolutely nothing is wasted.
Right, the story doesn't end with fuel. Think about it.
We've already gotten high-value food, the mushrooms, and clean energy, the ethanol. But what about everything that's left over after fermentation? In any other system, that's just more waste to deal with. But not here. Nope.
This is the final brilliant part of the puzzle. You upcycle all the leftovers. The solid stuff, you can burn it as biofuel to power the distillation process, making the whole thing energy self-sufficient. The liquid residues, you can put them in a digester to produce biogas, another form of energy. And that final, nutrient-rich slurry that's left? That becomes a supercharged compost that goes right back onto the fields. It's a perfect circle.
I love how the researchers who studied this put it. They said the entire system transforms a massive disposal problem into a profitable, cascaded, multi-stage refinement process. That's a fancy way of saying you're not just solving a waste problem, you're creating a whole chain of valuable products, food, then fuel, then energy, then fertilizer. It just keeps giving.
So when you step back and look at the big picture, you realize the future is circular. This is so much more than just a new fuel. It's a completely new model for how we can do things.
The main takeaway here is just profound. By simply copying nature's own cycles, we can design a society that's decentralized, that's resilient, and that can finally move past fossil fuels. We're talking about creating local, self-sufficient systems that make sense both for our wallets and for the planet.
And that leaves us with one last big question. Could our own communities become the self-sufficient energy farms of tomorrow? Imagine that. Small farms, maybe even entire towns, becoming their own power plants and food producers, all by turning their local waste into local wealth. It's a pretty powerful vision for the future, don't you think?